Hello everyone, I am Harsh Patil presenting you Embedded System Internship project titled Microwave Oven Simulation. During the internship, I was introduced to C language and embedded systems and programming of microcontroller using MPLAB IDE and PIC SimLab. Later, I was introduced to various peripherals of the microcontroller. These are the contents that I will be covering during the presentation. What is microwave oven? Basically, it is a kitchen appliance that cooks food by passing an electromagnetic wave through it. In various microwave ovens, there are various modes. In this project, we are going to implement 4 modes. They are first one micro mode, second one grill mode, third one convection mode, and fourth one start mode. First one micro mode. This mode is used to cook the food in a traditional way. Second one grill mode. This mode is same as micro mode, but in this mode the food is cooked plus grilled. Third one convection mode. In this mode the user can set the oven to preheat for a particular temperature. Fourth one start mode. It is a default mode. These are the requirements to build our project: MPLAB XIDE, X8 compiler, PIC SimLab, PIC 16F877A microcontroller, 16x4 CLCD, matrix keypad, and timer 2. Here are the few differences between microcontroller and microprocessor. Matrix keypad. This keypad is used when more number of inputs are required. With respect to microcontroller, rows are output and columns are inputs. Here is a PIC SimLab architecture. As you can see, there are various components like LM35 temperature sensor, I2C, GPIO, ADC, buzzer, LEDs, matrix keypad, CLCD, SSD, etc. The arrows facing opposite to each other are bidirectional arrows which represent that a component can receive and transfer data to the microcontroller. CLCD Character Liquid Crystal Display. In PIC SimLab, there are two types of display: 16:2 display and 16:4 display. 16:2 means it can display 16 characters per line and there are two such lines. The CLCD displays all the ASCII characters and some special characters. There are two types of communication mode: 4-bit mode and 8-bit mode. ISR Interrupt Service Routine. It helps to handle the interrupts. Here is how an ISR works. Whenever an interrupt is generated by a hardware device, the CPU temporarily suspends the execution of the main program and saves its current state in the program counter. Then the CPU jumps to the predefined address of the ISR associated with the specific interrupt. And as soon as the ISR handles the interrupt, the main program resumes. Timers. Timer is an important application in any embedded system which keep tracks of an operation in sync with system clock or an external clock. It has many applications like counter or to generate delay. There are 3 types of timers: timer 0, timer 1, timer 2. Timer 0 and timer 2 are 8-bit timers and timer 1 is a 16-bit timer. Timer 2 has an extra 8-bit register which allows user to set the pred for timer 2 independently.
Project implementation. First we have to build the project to create the hex file. The hex file has been created. Now this hex file we have to dump in the PIC SimLab. When we press the switch, the power screen will appear. This is the menu screen. The user has to select which mode he wants to use. So to use the first mode, we have to press 1, that is micro mode. The maximum power is 900 watts. Here the user can set the timing. If he wants to clear the timing, he has to press star. To pause the operation, we have to press 5. And to stop the operation, we have to press 6. If we want to resume the operation, then we have to press 4. As we can see that the timer is going on and the cooler is also running. As soon as the timer okay. Second is the grill mode. To operate grill mode, we have to press 2. So here we can see there is a set time screen appears. Here you can set the time. If the user wants to add some extra seconds, then he has to press 4. As you can see 30 seconds has been added. And if he wants to stop the operation, then he has to press 6. Third mode is the convection mode. To operate that, press 3. Here the user has to set the temperature. The maximum temperature the user can set is 180 degrees Celsius. If he adds greater than that, then it doesn't take the temperature. As soon as we press the enter, the oven will start to preheat for 180 seconds. Once the preheating is done, the user can set the time. So for example, let me take 20 seconds. So as now you can see the timer is also running, the fan is also running, and the buzzer is off. As soon as the timer runs out or becomes 0, the buzzer will start ringing and the screen will display time up. Fourth one is the start mode. It is default mode. Whenever the user presses that, the timer of automatically 30 seconds will be assigned. So this is our microwave project.